Hi everyone, this is Ruth and welcome back to my channel. This channel is mainly about my home lab where I build different setups, test networking tools, and experiment with infrastructure projects. My main goal with this lab is to practice cybersecurity skills in a real environment. So over time, I'll be building out different systems, security tools, and monitoring platforms. In previous labs, I explored SMB activity, Windows logging, and Splunk log collection. Today, we're taking that a step further by investigating Windows authentication events and building a simple SOC dashboard to monitor authentication activity. The goal of this lab is to understand how Windows records successful and failed authentication attempts, how those events appear in Splunk, and how we can visualize them through a dashboard. Let's get started. Before generating any activity, let's quickly review the environment. I have a Windows server configured with Sysmon and the Splunk Universal Forwarder. The Windows logs are being forwarded into Splunk Enterprise for analysis. I also have a Kali Linux machine that I'll use to generate authentication activity through SMB. For this lab, I'll investigate two important Windows security Event IDs, Event ID 4624, which represents a successful logon, and Event ID 4625, which represents a failed logon. These events are commonly investigated by SOC Analysts because they provide visibility into authentication activity occurring within an environment. To begin, I'll generate several failed authentication attempts. The first scenario will simulate authentication attempts using a non-existent account. I'm currently on my Kali Linux machine. To generate the activity, I'll use the following command. Before executing the command, let's briefly understand what it does. The SMB client utility allows Linux system to communicate with SMB services commonly found in Windows environments. SMB or server message block is a protocol commonly used for file sharing, printer sharing, and access to network resources. The -L option instructs SMB client to request a list of available SMB shares from the target server. In this case, the target server is 10.0.70.2, which is my Windows server. The -U parameter specifies the username that will be used during authentication. For this test, I'm specifying the user as a fake user. When this command is executed, Windows will attempt to authenticate the supplied account. If authentication succeeds, Windows records Event ID 4624, which represents a successful logon. If authentication fails, Windows records Event ID 4625, which represents a failed logon. Now let's execute the command. As expected, the authentication fails because the account does not exist on the Windows server. Although access was denied, this activity is still valuable from a defensive perspective. Even unsuccessful authentication attempts generate security logs and provide visibility into authentication activity occurring within the environment. To create additional activity for investigation, I'll repeat the process several times. This will generate multiple failed authentication events that we can later analyze within Splunk. Now that we've generated failed authentication attempts using a non-existent account, let's examine another common authentication failure scenario. In real environments, authentication failures are not always caused by invalid usernames. Sometimes the account exists, but the credentials provided are incorrect. Understanding the difference is important because both scenarios generate Event ID 4625, yet the underlying cause may be very different. To demonstrate this, I'll attempt to authenticate using a legitimate account while intentionally supplying an incorrect password. Returning to Kali Linux, I'll execute the following command. When prompted, I'll enter an invalid password. Although the administrator account exists, the incorrect credentials should cause the authentication attempt to fail, generating additional security events that we can investigate within Splunk. As before, the SMB client utility is attempting to communicate with SMB service running on the Windows server. The -L option requests a list of available SMB shares, while the -U parameter specifies the account that will be used for authentication. This time, however, I'll intentionally enter an incorrect password. After submitting the credentials, the authentication fails. Although the account exists, Windows is unable to verify the supplied password and denies access. At this stage, we've generated multiple failed authentication attempts involving both a non-existent account and a legitimate account using invalid credentials. Now let's investigate how Windows recorded this activity. Switching into Splunk, I'll open Search and Reporting and begin searching for failed authentication events. Immediately, Splunk returns Event ID 4625. Whenever Windows receives an authentication request that cannot be successfully validated, this event is typically generated within the security log. Now, let's investigate the details as a SOC analyst would. One of the first questions we should ask is, who attempted to authenticate? To answer this, I'll review the account name field. Here we can observe accounts such as fake user and administrator. This immediately provides valuable context. We can see that both a non-existent account and a legitimate account were involved in failed authentication activity. Next, let's determine where these authentication attempts originated. To answer the question, I'll review the source network address field. This field identifies the system responsible for generating the authentication request. Reviewing the event details, we can see the activity originated from my Kali Linux machine. This allows us to correlate the Windows event with the activity we previously generated from Kali. The next question an analyst might ask is, why did the authentication fail? To answer this, I'll review the fail reason field. Windows records the reason the authentication attempt was a known username or bad password. This information is particularly valuable because it helps analysts distinguish between different types of authentication failures and identify potential attack patterns. Finally, I'll review the event timestamp. This allows me to determine exactly when the authentication attempt occurred and correlate it with the activity I generated during the lab. At this point, we've confirmed that Windows successfully recorded the failed authentication attempts and that Splunk is receiving those events for analysis. Now that we've investigated failed authentication events, let's generate a successful authentication event and compare the results. Returning to Kali Linux, this time I'll use the administrator account and provide the correct password. As before, the command is requesting a list of SMB shares from the Windows server. However, unlike the previous test, I'll now provide valid credentials. After entering the correct password, the SMB shares are successfully displayed. This confirms that authentication was successful and that the Windows server granted access to the request. This confirms that authentication was successful and that the Windows server granted access to the request. Now let's investigate how Windows recorded this successful authentication. Returning to Splunk, this time I'll search for successful authentication events. The results show Event ID 4624 entries. Event ID 4624 represents a successful logon. Whenever Windows successfully validated credentials and grants access, this event is recorded within the security log. Let's investigate the details. The first question is, which account successfully authenticated? Reviewing the account name field, we can see that the administrator account successfully authenticated against the Windows server. Next, let's identify the origin of the authentication request. Reviewing the source network address field, we can confirm that the request originated from the Kali Linux machine used during the lab. This correlation helps validate that the event was generated by the activity we performed earlier. Another useful field is logon type. Reviewing the logon type value, we commonly observe logon type 3. Logon type 3 represents a network logon. This is consistent with SMB authentication because the authentication occurred across the network rather than directly at the Windows console. Finally, I'll review the timestamp. The event occurred immediately after the successful authentication attempt was generated from Kali. At this stage, we've successfully validated both successful and failed authentication events. Now that we've investigated both event types individually, let's compare them. Event ID 4624 records successful authentication activity. Event ID 4625 records failed authentication activity. Although both events are related to authentication, they provide very different outcomes. One indicates that Windows successfully validated credentials and granted access. The other indicates that authentication failed and access was denied. Together, these events provide valuable visibility into authentication behavior across an environment. This is one of the reasons Event IDs 4624 and 4625 are among the most frequently investigated Windows security events within a security operations center. Now that we've investigated the raw authentication events, let's transform that information into something that can be monitored more efficiently. While searching through individual events is useful during investigations, dashboards provide analysts with a centralized view of activity and help identify patterns much more quickly. To do this, I'll create a new dashboard studio. I'll name it Windows Authentication Monitoring. The first panel will display the total number of successful logons. This provides an immediate count of successful authentication activity. Next, I'll create a panel for failed logons. This allows analysts to quickly identify authentication failures occurring within the environment. With the key authentication metrics displayed, the next step is to understand how authentication activity changes over time. To achieve this, I'll create Authentication Trends panel. This panel provides a timeline view of authentication activity and helps identify spikes or unusual behavior. After analyzing authentication activity over time, it's also important to identify which user accounts are generating that activity. To provide this visibility, I'll create a panel showing authentication activity by account. This allows analysts to identify which accounts are generating the most authentication activity. Finally, I create a panel that compares successful and failed authentication events. This provides a quick visual comparison of authentication outcomes and helps analysts to understand the overall authentication profile of the environment. At this point, the dashboard is complete. The dashboard now provides visibility into successful logons, failed logons, authentication trends, account activity, and authentication outcomes, allowing analysts to monitor Windows authentication activity from a single interface and quickly identify potential suspicious behavior. Today, I investigated Windows authentication activity using Splunk. I generated both failed and successful SMB authentication attempts from Kali Linux. I analyzed event IDs for 624 and for 625 to understand how Windows records authentication activity. I then created a Splunk dashboard to monitor authentication events. This project demonstrates how defenders can investigate authentication events, build useful monitoring dashboards, and gain visibility into authentication activity within their environment. Thank you for watching, and I'll see you in the next lab.